All right, hello everyone. This video is going over the polynomial vocabulary. If you don't have your guided notes up or some kind of note-taking device or whatever, then pause the video real quick and get that up so you can follow along. Like I said, it's a vocabulary, so I'm just going to go over some of the vocabulary. This video should be pretty quick, honestly. A lot of it's already there for you. I'm just going to be clarifying some things and saying it in my own words, I guess. The first thing on the guided notes you can see is it talks about writing down definitions of variable and coefficient. So variable, if you've taken any kind of science class, and actually any kind of class in general, a variable is something that changes. In our instance, or I guess you could say instance, but yeah, in our instance, the thing that changes is the number, right? So for usually in math, the variable is a letter. So like 3x squared, the x is our variable. We don't know what number goes there. Essentially, it's a placeholder saying we can kind of put whatever number we want there. We just don't know which one is there currently. So it's a placeholder. It's saying that a constantly changing number is there. So the variable is usually our letter in mathematics. Well, in mathematics, the variable is always a letter, but in other places, be careful with that. For example, in physics, the letter C is usually speed of light. So it's an actual number. It's not a variable. It doesn't change. Okay, so just be careful with that. But in mathematics, whenever you see a letter, it's a variable. Just means it's a placeholder for a number that we don't know it's there yet. A coefficient. Okay, that is the number being multiplied. So the number being multiplied to the variable. All right. So in this instance here, the 3x squared, number being multiplied to the variable is 3. So 3 is our coefficient. Okay, this 2 is an exponent. You should have went over that last year in SM1 when you did exponential equations. So this is an exponent. This is called a coefficient. Okay. Now, if I were to have a polynomial like this number right here is called the leading coefficient. I think I forgot to put space on the guided notes for that, so make sure you write it somewhere. Okay, the coefficient in front of all the other terms is the leading coefficient because it's the one that leads. It's the first one there. Okay. Now, the next part, it gives you some groups to look at of different expressions, and it asks you to take a moment to look for patterns. So please pause the video and look for patterns between the three groups here and write down your thoughts below. So go ahead and pause now. All right, hopefully you paused the video and did what I asked. I promise you will learn so much more and things will be so much easier if you do the things I ask you to do. I don't do them. I don't talk just to let out hot air. There's a reason that I do them. Anyways, now that you have your, I don't want to say guesses, but you've logically thought through the patterns here, on the second page, it shows you what the patterns are. Okay, so the names for each term, I guess you could say, if we have one term, okay, one term, this is a monomial. Okay, a monomial is either just a number, so if it's just -2, or just a variable, okay, or the product, multiply the product of a variable and a number. So all three of these are considered monomials. Okay, mono meaning one, meal meaning number. Okay, or nomial meaning number, but it's kind of, you don't say mononomial, it's monomial. Now, if there's two monomials together in one expression, for example, x squared plus 5, see there's a monomial here, and then there's another one here, okay? Then this is called a binomial. Okay, bi is a prefix meaning two, like a bicycle has two wheels, a binomial has two terms. Okay, 1, 2. If there's three terms, I'm sure you can guess. -8. It's called a trinomial. Tri meaning three, it's the prefix for three, like a tricycle has three wheels. Triceratops had three horns, right? So trinomial is three terms. Okay, 1, 2, 3. Three different monomials. And then anything bigger than a trinomial, we just say the number of terms and then polynomial. Okay, polynomial is the umbrella. This is the umbrella term for all of these. Okay, so any combination of monomials or just a monomial itself, any number of combination of monomial, they're all called polynomial, meaning multiple terms. It doesn't matter how many terms there are, it's called a polynomial. That's the umbrella term. So in this class, I'll usually say polynomial unless it's something specific like this that we're talking about. All right. And once again, that's here in your notes too. All right. The other vocabulary we need to go over is a way of describing a polynomial. The polynomial is described by its degree. So here I'm going to write 2x squared plus 2x plus 2. Okay. The degree of a polynomial is the largest exponent that's found in the polynomial. So for example, here the largest exponent is 2. Now remember, here there's technically an exponent of 1, and here there's no exponent, so it would be 0. The largest exponent is a 2, so the degree of this polynomial is 2. Okay, if we had, let's go back to one that we had before, just a second ago. We had negative 7a squared plus 9b minus 4b to the third plus 6. Okay, if we look down here, we look at all of our exponents. Here we have an exponent of 2. Here we have an exponent of 1, exponent of 3, and an exponent of 0. Okay. The biggest exponent here is a 3. So this polynomial is degree 3. And that's the definition. Now we use specific words, and you can see that there's a little chart here for you. Now it goes past 5th degree, right? There's 6, 7, 8, and they all have specific words, but I don't really worry about after 5, especially in high school, because we never really get past a 5th degree polynomial or a quintic. So I'm going to write this down. Degree 0, okay, is called a constant. The reason for that, for example, if you look here, the number 6 is degree 0. It's a constant. The number never changes, right? It's always going to be 6. It's never going to change to something else. It's always going to be a 6, so it's constant. It also has to deal with the variable. It doesn't have a variable here, so it's never going to vary, so it's constant. All right, degree 1 is called linear. And you should remember this from last year in SM1, or if you're in SM3, you should remember it from a couple years ago, or even and SM2. Degree 1 makes a line when you graph it. So if I have x plus 2 equals y, that makes a line. Well, this x has an exponent of 1, so it's degree 1, makes a line, so it's linear. Okay. Degree 2, for example, this one right here, is called quadratic. Now, I know it sounds kind of weird, like, why is that 2? Quad sounds like 4. It comes from how you would say it in Latin. Okay. Those of you that speak Spanish, it'll probably make a little bit more sense to you, because Spanish is more closely related to Latin. But that's what it comes from, is from the Latin word. Okay. Degree 3 is called cubic. This one should make a little bit more sense. It has the word cube, right? So cube has 3 dimensions, so it's cubic. 4, this one sounds a little bit better, is quartic. Quartic, kind of like a quart of milk. It takes 4 quarts to a gallon, or 4 quarters to $1. So degree 4 is quartic. And then degree 5 is ketic. Okay. That's also Latin. For example, the name Quintus, which was a Latin name, meant the fifth son. If you have quintuplets, you have 5 kids, right? Or 5 kids all at once, I guess you could say. Anyways, these are the adjectives that we would place on a polynomial to describe its degree. Okay. Let's move on to the next definitions here, and we can do some practice. Okay, the last vocabulary word that I want to talk about that's extremely important, is going to make your life super easy if you follow it. It's called standard form. Okay, it's right below the degree adjectives here. Standard form. Okay, so standard form of a polynomial. For example, if we had the one that we just had, negative 7a squared plus 9b minus 4b to the third plus 6. Okay. Standard form is this polynomial, but the terms are written from biggest exponent to smallest exponent. So here the exponent is 2 on the variable, here it's 1, here it's 3, and here it's 0. Okay, so if we want to write the polynomial in standard form, we take the term with the biggest exponent, so minus 4b to the third, and then the next biggest, minus 7a squared, and then the next, 9b plus 6. So you can see our exponents are in descending order, from biggest to smallest. And this is standard form. This is going to make your life extremely easy. Please write your answers like this. Do all your work in standard form. If you don't, it's going to get confusing. Okay. So I highly, highly, highly recommend you write all your stuff in standard form. Okay. The only time I will not write in standard form is if I want you to practice writing in standard form and having you rewrite. But I will always put stuff in standard form. So right now, pause the video. You can see at the bottom there, it says take a second to determine which of the following polynomials is in standard form and which is not. So take a second there, pause the video, and write your answers. All right, you should have had your answers. So the first one is not in standard form. You can see that we have negative 72x to the 7th. The exponent 7 is bigger than 6, so it should be out front. Okay, so we have 5x to the 6th plus 12x to the 3rd minus 72x to the 7th minus 111x. Okay, now all the coefficients are in descending order, but we don't care about that. with standard form, right? We care about the exponents. So this 7 is bigger than the 6 and the 3. So if it was in standard form, it would be written out front. Okay, so that first one is not in standard form. The second one is in standard form. Okay, that's our last vocabulary term. On the back side, or I guess I printed mine out, but the last page, there's 6 questions. Let's go over it together, and then I'll leave you to do your practice problems. Okay. So negative 7n to the third. It says we want to name this polynomial. We want to use the name of the polynomial, so like monomial, trinomial, binomial, and then also the adjective of the degree describing it. So this one, it's a monomial, right, one term, and the degree is 3, so it's a cubic monomial. Okay, cubic degree 3, one term monomial. The next one, minus 5m squared plus m plus 9. There's 3 terms, so it's a trinomial. The biggest degree is 2, so it is a quadratic trinomial. All right, this next one, negative 10. There's only one term, so it's a monomial, but it has a degree 0, right? Because there's no variable, so the degree is 0. It's a constant, so we call this a constant monomial. All right. Now we have negative n to the third plus 3n squared. Okay, the largest degree is 3, or not largest, excuse me. Largest exponent is 3, so the degree is cubic. So as a cubic, there's only 2 terms, cubic binomial. Uh, 7 minus 10x plus 10x squared. Now it does say that if the polynomial is not in standard form, you need to rewrite it in standard form. So let's do that real quick. Okay, here's our biggest exponent. It's 2, so we have 10x squared minus 10x plus 7, right? This is a positive 7, there's no minus sign. Okay, largest exponent is a 2, so it's quadratic. Okay, and there's 3 terms, trinomial. Okay, and the last one, I put that on there, not to be tricky, but just to, it's an example that allows me to teach something else pretty simply. So 6 plus 6m to the 8th, it's not in standard form, right? This is exponent of 0, this is 8, so let's rewrite it in standard form. 6m to the 8th power plus 6. Okay, so it is a binomial. There's two terms. Now this is a power of 8. I told you that it has a specific name, but if you see this just for now in this class, just write binomial of degree 8. Okay, binomial of degree 8. And that's it for vocabulary for the polynomial operations. There's a lot of vocabulary. There's more vocabulary, obviously. But for this module, this is the vocabulary.